found this really cool research article called Antarctic microbial mats, a modern analog for Archean lacustrine oxygen oases.
Are you suggesting that there was oxygen in early Earth?
Exactly. See, the Earth formed around 5 billion years ago. About 500 million years later, a dense atmosphere emerged due to volcanic degassing of the interior of the planet. The early atmosphere consisted of hydrogen gas, water vapor, methane, and carbon oxides. The hydrosphere formed around 4 billion years ago through the condensation of water vapor. This led to the formation of oceans that started accumulating sediments. Earth's atmosphere didn't change from a reducing to an oxidizing atmosphere until 2.45 billion years ago. The influx of oxygen into the atmosphere was actually caused by cyanobacteria that produce oxygen through photosynthesis. This monumental change of Earth's atmosphere is known as the Great Oxidation Event.
So, were cyanobacteria not producing oxygen before the Great Oxidation Event?
Well, evidence suggests that they were, but not in large enough quantities to cause a significant change in the atmosphere. Researchers determined that oxygen oases formed in benthic microbial mats and not the open ocean. The open ocean would not have been an ideal place for oxygen accumulation because of its rapid mixing and gas exchange with the atmosphere, but benthic microbial mats could be plausible because they were better suited for oxygen buildup. Until now, we didn't have a good representation of what oxygen oases in these mats would have looked like, which is why the discovery of oxygen oases in the Antarctic is so exciting.
Where in the Antarctic did they find this oxygen oasis?
Lake Fryxell. It's an ice-covered lake in McMurdo Dry Valleys in Antarctica. It's the ideal representation of Archean oxygen oases because it is stratified, so the nutrients don't cycle, which results in a significant portion of the lake being anoxic or oxygen lacking. But it still receives some light in some areas, allowing for the growth of benthic microbial beds.
Wait, I'm confused. How do the researchers test the hypothesis of their oxygen oases? I mean, how do they know the microbial mats in Lake Fryxell were analogous to those that predated the Great Oxidation Event?
The researchers measured dissolved oxygen, temperature, conductivity, and water depth 50 millimeters above the mat surface. Observations of oxygen concentrations in a water column in Lake Fryxell were made using specialized instruments and the help of a diver. The cyanobacteria and diatomorphotypes in the benthic mat were identified using a light microscope.
Let me guess, they found the water column had significant levels of oxygen.
Well, yes and no. The water column in Lake Fryxell was not supersaturated with oxygen all the way through, only to the depth of 9.1 meters, and then gradually decreasing until 9.8 meters. And everything below 9.8 meters, no oxygen found whatsoever.
Why no oxygen below 9.8 meters?
Because oxygen concentrations in the microbial mats depend on how dense the cyanobacteria are and the amount of light available to them. Since the wavelengths the bacteria receive have to travel through layers of frozen water, the photosynthesis efficiency is low. So, during periods of low sunlight, especially during the winter, the oxygen oases disappear completely.
The Archean oases were productive enough to form zones with high oxygen concentration, but not enough to oxidize the surroundings. So the fact that the areas above and below the oxygen oases in Lake Fryxell are anoxic makes it an ideal modern analog to study chemical signatures of oxygen oases prior to the Great Oxidation Event.
So you're saying that the Archean oxygen oases led to the Great Oxidation Event?
Well, there's a hypothesis that says that the Archean oxygen oases might have slowly expanded as more species of cyanobacteria evolved and became more photosynthetically efficient. They might have then spread to the ocean and started oxidizing the elements there, which would have decreased the exchange of reduced gases with the atmosphere, essentially preparing Earth for this big event.
By studying the chemical effects of the oxygen oases in Lake Fryxell on its surroundings, we can identify special markers that can help us establish the extent of Archean oxygen oases and their impact in the historical environment.
Gee, that was a cool article.